Hello, everyone. Welcome back. In the preceding video, we started to introduce the implementation of my hash map. If you have studied this program, you probably noticed that we have this default initial capacity is 4, and the maximum capacity is 230. These numbers are power of 2. Why? There's a good reason. Now let's look at this method get key. We're going to map the key to the index in the table. So we get the hash code from the key and then invoke this hash method to hash and compress it to the table. And let's look at this hash method. Now this is the hash method, and we get the supplemental hash. So just reshuffle it to make it more even. So this is what we do here. And then you see here, we are not doing the remainder. We are using this bitwise AND operator. This is actually the same as if you're using remainder capacity. Let's look at the book for this. So here's the table size n. If the table size n is an integer power of 2, then this remainder is the same as using this AND. You have hash code AND n-1. This AND is a lot more efficient than the remainder. So it takes less time than the remainder. So that's why we're using it. We can do it really fast for performing this mapping the key to the hash table. Now let's go back to the implementation for my hash set. We're going to make my hash set a subtype of the collection interface. So those are my constructors. I have all these methods already in the Java API collection interface. So we're going to have this my hash set. So again, look, I'm using this a power of 2, and for my capacity, default capacity, and this is the maximum capacity. All right, so this is very similar to my hash map implementation. And please study this after the video. Before I leave, I want to bring up again this the hash. So let's see the get. We're going to see if we can use this to the add things. So look, we're going to add this element to the set. So now first you're going to check if this element is already in the set. If so, you're going to return false. So all the elements in the set cannot be duplicated. And after this, we're going to look at the size. If you increase size by 1, where this exceeds the load factor threshold. If so, we're going to check the capacity if it's already the maximum, and then we have to say, hey, this exceeding maximum capacity, run time exception. Otherwise, we're going to perform rehash. So rehash is this. Look at the rehash now. Rehash is to increase the size of the table. So first, we get everything from the set to list. So we're going to put this to this list. And now look, the capacity is doubled. This is the double the capacity. Shift to the left one position. And now we create this new table. And this is the new size. And now we're going to add everything back to the table, invoke this add method. So every time you add it, and that's going to be increase the size by 1. So look, go back to the add. See, we're invoking this add here. So this is add, is to increase the size here. All right, so when you add here, you have this hash mapping, map this elements, the hash code into the bucket index. And look at this. If this, there's no bucket in the table, so we're going to create a bucket as linked list. And now we're going to add this E element into this bucket. Now look this hash here. Please note that E.hash code, for any object you have a hash code, this returns integer. It may be negative. So, but you are doing, when you are doing this hash here, see what happens here. It's going to be positive because you are performing this, and this number is always positive, and a positive and with a negative will be still positive. So you'll not have a problem of getting a negative index. Now, if you look at the code and see the implementation, you'll see that all these operations for search, for the add, and for remove, these are all of one-time complexity. So these are all super efficient. Thank you for watching this video. See you on the next video.